Hello students, I would like us to move on to question number 4, and the question is on quantity of heat. And the question read, state two differences between boiling and evaporation. The differences between boiling and evaporation are very straight from the textbook, page 232 of our Form 3 KLB book if you have the newest edition. And the differences are evaporation takes place at all temperatures, while boiling takes place at a specific temperature. Another difference is evaporation normally takes place on the surface of the liquid and there are no bubbles that are formed. But for boiling, boiling takes place all through the liquid and some bubbles are formed. Decreasing the atmospheric pressure increases the rate of evaporation, while decreasing the atmospheric pressure lowers the boiling point. So those are the three differences between boiling and evaporation. The next question, I hope it will be clear for us. 200 grams of solid was uniformly heated by 0.2 kilowatt heater for some time. The graph in the figure below shows how the temperature of the solid changed with time. The first question for this graph read, explain what is happening between OA and AB. So for us to be able to explain what is happening between OA and AB, we can just get that explanation from the graph. From OA, between O and A, the temperature is changing from 40 to 80. So we can talk about the temperature increases between OA. Why is it increasing? The solid is absorbing some heat, and that heat leads to an increase in temperature. Between AB, the temperature is constant. Why is it constant? The heat that is absorbed by the solid is used for melting. So melting is taking place at point AB, and that's why the temperature is constant. So interpretation of graphs becomes very important, especially we find much of this work under linear motion. And I've discussed the graphs of linear motion on View SASA under paper 1 and also the review of paper 1. So I'm kindly requesting that you can still go through the work for the revision of the year 2019 KCSE for you to be able to know how to interpret the graphs quite well. And then question 2, calculate the specific heat capacity of the solid. The keywords there are specific heat capacity and the solid. So if you look at the graph, for the graph we have this, the heating starts when we have a solid. So at O to A, that is where we have the solid. AB, melting is taking place. From B to C, because melting has already taken place, that is a liquid. So if they ask for the specific heat capacity of the solid, we use the path OA, because that is where we have the solid alone. I noted most of us were using the whole time of 50 minutes for that experiment, but that was so wrong because for it we only have a solid between O and A. So what you are supposed to do is to get the time between OA and also the change in temperature, and the mass was given. So the time will enable you to find the quantity of heat. So the quantity of heat here will be calculated from the formula Q is equivalent to power times time. The power was given as 0.2 kilowatts. So you are supposed to take the 0.7 kilowatts, you multiply 0.2 kilowatts, sorry, you multiply by 10 and then times 60 to change the time into seconds. And if that is done, then the quantity of heat will be 1.2 times 10 power 5 joules. I hope that is clear. And then apart from that, you also have the change in temperature, which will be given as 80 minus 40, which is 40 kelvins, and the mass is given as 200 grams. So using the formula Q is equals to mc theta, C normally refers to the specific heat capacity. So on the formula, Q is equals to mc theta, you make C the subject of the formula. That is C is equivalent to Q over m theta. substitute everything into the formula, and then we'll get the value for the specific heat capacity. And I've already calculated for you the value over there. And then question 2, red, calculate the specific latent heat of fusion of the solid. Specific latent heat of fusion of the solid refers to the quantity of heat that is required to do what? To change the state of a solid, the state of a substance, a unit mass of a substance, from a solid to a liquid without change in temperature. So from the definition, for us to be able to get that, we are supposed to use the graph between AB, and between AB, the time there is 20 minutes. So 20 minutes times 60 seconds, that one gives us 1200 seconds. And then from the time, we calculate the quantity of heat that was absorbed during that melting. So it will be Q is equivalent to PT, which is 1200 seconds, times 0.2 kilowatts, giving you 240,000 joules. So that is the quantity of heat that was used for melting. But if you remember, the quantity of heat used for melting can be given by the formula MLF, where LF refers to the latent heat of fusion. So you make LF the subject of the formula, and if you make it the subject of the formula, it will be LF is equivalent to Q over M. So you take Q, divide by M, and then you get the specific latent heat of fusion. So apart from the graphs that we've been given, there are a number of graphs that are normally given under specific latent heat